All right, everybody, we are going to work on 3 different sections tonight, so that's quite a bit. Sorry. The good news is there are 3 of the really short ones. I apologize every time that an email comes in, my computer dings. Oh, hang on, we got somebody coming in. We're going to wait on them. Hey, Kayla, can you hear me?
Yes, I can hear you.
You can hear me perfect. Listen, you are the only person that's here tonight, so so far. That may change, who knows. Let me tell you what my plan was, and then let me ask you a couple of questions before I kind of get started.
Okay.
My plan is to go over some problems out of each of the 3 sections that are due tomorrow. Which is section 1.6, 5.1, and 5.2. It's a heck of a lot of stuff. The good news is they're kind of short. But let me, before I decide whether to scrap my plan or try to adjust it or whatever, since you're the only one here, have you attempted those? Are you just starting them?
I'm on 5.1, and I did like the very first little part where it says like seeing if there's a solution. The
Yes.
polynomial is the solution.
Okay.
And I understand, but then you start getting to the graphs, and I don't get it.
Okay. All right. So how about I do this then? So you've completed section 1.6?
Yes.
Yes, perfect. Okay. Then what I'm going to do, because I do need to do a couple of problems for that since we record these, let me go out of order. So let me start with 5.1. I'll do 5.2, and then I'll go back and do 1.6 in a second. And that way, if you want to stay for the whole thing, you can. If you get what you need and you want to cut out, then I'm not making you sit here for a little bit at the beginning listening to something that you already understand. Is that good?
That's fine, yeah.
Perfect. Okay, so we're going to start with section 5.1. And since you're here and since you have specific things that you're having trouble with, do you happen to have one of those questions? Can we just work one of those instead of work?
I kind of stopped because I'm not really sure. Once it got to the graph, which was kind of towards the beginning, so.
Okay, did you get one that was solved by the quadratic formula?
No.
No? Okay. So we may need to do, I'm pulling up y'all's stuff right now just so that I could, because I did not write a graphing one down. And so I'm pulling up section 5.1 just so that I can look at a graphing one real quick. So that way we can talk about that. So give me 1 second. I came up to my work, so hopefully my computer's a little faster. When I did this at home, it didn't go well. Living in the country. Okay, but while this is pulling up, let me go ahead and because the quadratic formula always gets people, so let me go ahead and we're going to do one of those, and then we'll do a graphing one next, okay?
Okay.
Especially since you haven't gotten to one of these, because you will, I promise. All right, so we are going to do this problem right here. So we are going to, the instructions are basically to solve it. And we get 5x squared minus 50x plus 25 equals to 0. And so we can do a couple of things. You could try to factor this, but most students are really bad at factoring with something that has what I'm going to call this leading coefficient right here of something other than 1. And the quadratic formula is the only thing that works all the time. So that's what we're going to try. Okay. So if you'll remember, I'm going to write it over here. This is our quadratic formula. Negative b plus or minus big huge square root sign b squared 4ac over 2. Perfect. Okay. And I'm going to tell you straight up. Okay. I promise it's there. I've already written your midterm exam. You have to know the quadratic formula. I'll guarantee it. It's there. So make sure you memorize that. And so remember, this is A. A is always the number that goes with the x squared. This is B, and I'm going to make that line a little bigger because it includes that negative sign right there. So that's always the number to the X, and then there's C. And then what I'm going to do first, you can skip steps at will, but when I'm doing this with students that I don't see on a regular basis, I don't tend to skip steps. So if I go a little too slow paced, I'm sorry. What we're going to do first is just plug in, nothing else. Just put numbers in there. So the first thing that I see in this formula is this negative sign. So I get negative. And then B itself is also negative. So that's where I get that double negative right there. I'll clean it up in just a second. And then we've got plus or minus, that big square root sign. And then we've got negative 50 squared minus 4 times A, which is 5, times C, which is 25. And I didn't make my square root big enough, so I'm going to make that a little bigger right there. All of that divided by 2 times A, which is 5. Okay, so far, are we happy?
Yes.
Perfect. Okay, what I'm going to do, just to give me a little room, I'm going to erase this formula over here so that I can kind of move over here in a second. So what I'm going to do first is I see that negative 50, and we don't ever have a double negative, so a negative is a positive 50. And then we've got plus or minus. And then you can certainly use your calculator on something like this because most of us probably don't know what 50 squared is off the top of our head. And so if you square that, remember, anytime you square a negative number, you do get a positive number. And so we get 2,500. And then that's going to be minus. And then 4 times 5 is 20 times 25 is 500. And then all of that is over 10. And then what I always tell students is don't get cancel happy. People love to cancel. Trust me, they do it all the time in every class I teach. But you want to deal with that square root first before you try to cancel that 50 and that 10. So we're going to do 50 plus or minus. This becomes the square root of 2,000 over 10. And then I'll be honest, this is the reason that I picked this, because this is typically a very tough problem. And if you already did section 1.6, then you've already done problems like this. If you grab your calculator and you plug in the square root of 2,000, it's an ugly number. It's a decimal. You can't, it's not real pretty like the square root of 25 or anything. And so what we're going to have to do is we're going to have to do a little bit of simplifying. And I like to kind of do everything on one page here so that we don't lose the whole problem. So I'm going to erase this. We're going to come up here and we're going to simplify. So if I start with 2,000, well, I know that that is, I'm just going to do this 2 times 1,000. Now I could split it up lots of other ways, but that's one of them. And then 1,000 is 10 times 100. You agree with me there?
Yes.
All right. And then I'm going to have to erase a little more. I'm going to have to erase that original equation right there. Then what I can do is I can split up 10 into the only thing that 10 will split up into, which is 2 and 5. And I can split up 100 into 10 and 10. And then once again, I get a bunch of 2s and 5s. That's a lot of 2s and 5s. If you look at it, if you count, we have 1, 2, 3, 4 2s. So I'm going to kind of just write this part down. So the square root of 2,000 is 1, 2, 3, 4 2s. And then it is 3 5s. I said that backwards. I was about to say 5 3s. It's 3 5s. That's an ugly one. I mean, when I came up with this example. Whew. All right, so now let's ask this. Do you remember what you do once you get it to this point to simplify it? And I'm not trying to pick on you. If the answer is no, it's no. Who cares? We'll just figure it out.
Don't you move one of them in front?
Yes, but there's a kind of a caveat. So for every pair, so see, I have two twos there. That means 1 2 gets to come out in front. And then
Okay.
I have another pair here, so another 2 gets to come out in front. And I have another pair here, which means that the 5 gets to come out in front.
Okay.
So I have a 2, and a 5. And then I have inside the house a lonely little 5 that doesn't have a friend to play with. Okay. And so what you want to remember is that you multiply these numbers out here. So 2 times 2 is 4 times 5 is 20. And so that ugly square root of 2000 simplifies to be 20 square root of 5. And that is a lot. All right, so now here's your next problem. You're still not done. It's like the never-ending problem. If you look at this, you have a 50, a 20, and a 10. What are 50, 20, and 10 all divisible by?
5.
Go even bigger.
10.
There you go. So divide them by 10. So 50 divided by 10 is 5.
5.
20 divided by 10 is,
4.
careful, 2. Because you're dividing. Yeah, I know. You went back to your 5. And then 10 divided by 10 is 1. And so what you get is 5 plus or minus 2 square root of 5 over 1. And you don't really need that over 1 because anything divided by 1 is the same thing. So I'm just going to come in here and I'm going to erase that real quick. And this is our final answer. That's a lot. All right, but let me stop right there. What do you think? Good, bad? Do we need to talk about something?
So then we don't need to do 2 separate answers with 5 plus 2 square
Okay.
5 and
That depends on how Hawks is asking you for it. If they give you, they can do a couple of things. So they can give you, and I've seen them do it both ways, and so it really matters how they ask for it. They may give you something like this, a box, and then a box, and they'll say, give me one answer in each box. And if they do that, then yes, you need to do 2. Oh, it's 5. Man, I'm getting too happy here. Sorry. All right, you would need to do 5 plus 2 square root of 5, and then you would need to come over here and do 5 minus 2 square root of 5. Or
Okay.
I've seen them do it this way, where they put the plus or minus in between the 2 boxes. And if they do that, then you can just say, hey, 5 plus or minus, and then this part would be 2 square root of 5. It just is a matter of how whoever was writing the homework problem managed to set it up for the answer.
Okay.
All right. So now I found one of your graph ones. You ready? You don't sound too thrilled. It's not bad. I promise. I promise. I think I know what's getting you. We'll get it. It'll be good. So I promise you won't leave here without knowing what you're doing. Okay. All right, so let's get rid of all this. Now I'm going to tell you my downfall as a teacher is that I really should have taken art class and I don't draw well. So when I draw this in just a minute, I'm going to apologize in advance and I'm going to promise you that Hawks draws much better than I do, okay? So their graphs will be a whole lot prettier. Kind of bad, but it's the way that it is. Okay, so I happened to go to somebody that has already worked this and I just pulled up their homework problem. So this was a homework problem. They're randomly done. Of course, yours may be different answers or whatever, but it's going to be something similar. And they give you this right here and they say a couple of things. The first thing that they do is they say identify the correct graph. Now, unfortunately, I don't have a whole bunch of choices, but that's okay because I'm going to show you how to find the correct graph in just a second. And then they say enter the intercepts as ordered pairs. And what I am going to claim is that essentially, Kayla, that's backwards, okay? In order for you to identify the correct graph, you need to know the intercepts. So what we're going to do is, even though their instructions say find the correct graph and then do the intercepts, we're going to flip-flop those, okay? So we'll get just a second. Now, when we talk about intercepts, there are two. So they weren't specific, but if you were to scroll down on Hawks and you were to look, they actually have answer blanks for both X-intercepts and Y-intercepts. So when they say enter the intercepts and they're not specific, they mean both. All right.
Okay.
So now that we kind of know what we're supposed to do, I'm going to remove these instructions so that we have a little bit of room to work. And we are going to start with the X-intercepts, not because you have to, just because X comes before Y. I don't know. I'm going in alphabetical order tonight. So to find X-intercepts, let's make ourselves a little note. So to find X-intercepts, I'm going to abbreviate right there. You take each factor. And if you don't know what a factor is, hang on 1 second, we'll talk about that. And you set it equal to 0 and solve it. And I'm going to make sure with that funky sound that I don't have anybody. Oh, looks like we got somebody else joining us. Hang on, there we go. All right. Somebody else is coming in the room, but that's okay. They'll be here in a second. I figured that's what that noise was. Okay, so if you look at this particular problem, you actually have 3 factors. The factors are what's in the parentheses. So I'm going to kind of underline them in a different color. That right there is 1 factor, that thing that's set off in parentheses. This one right here is the next factor, and then this one right here is the last factor. So I'm not promising you that every single homework problem that you deal with is going to have 3 intercepts. This one has 3 intercepts because it has 3 factors. I could give you something that only had 2 factors and it would only have 2 X-intercepts. Okay. Yeah. So what you're going to do is come in here, and I'm going to go back to my little green color. Here we go. And you're going to take that first factor, X minus 3, set it equal to 0. Now, if I've got X minus 3 equal to 0, what are we going to need to do to solve that?
Add 3 on both sides.
Perfect. Perfect. So what we do is we get X equals 3. But then if you'll remember when I wrote down those instructions, it said enter them as ordered pairs. Remember, an ordered pair, I'm going to write over here, is always X comma Y. And so you solved this and X was 3 at at an X-intercept, Y is always 0. So that's going to be 3 comma 0. So in a minute, when we talk about graphing this, we are going to get a graph that has the 0.30 on it. That's what we're going to be looking for. Okay. But that's not enough information. That's not my only X-intercept. I'm going to go to this second factor, X plus 4. We're going to do the same thing. Set it equal to 0. We're going to subtract 4. And that's going to give me X equals -4. And once again, it tells me I got to write it as an ordered pair. So on an ordered pair, X is always first. And then since this is an X-intercept, I know that my Y is 0. That's just a rule. All right, and then you got another one. And so now we've got 2 minus X. We're going to set that equal to 0. And I'll be honest, this one is the one that's kind of the mean one. Hawks likes to throw in things to just make sure everybody's on their toes. This is the one that makes sure you're on your toes because it's got that pesky minus right there. So if we subtract 2 here, which is what most people do, but then what they'll tell me is they'll tell me that my intercept is -2. But if you look at this, this says negative X is -2. And so what I need to do now is divide both sides by a negative, and that tells me that X is
positive.
Yeah, so it's really easy on this one to mess up your positive and negative sign. And then remember, once again, we have to write that as an ordered pair. So we've got 2, 0 right there. So the good news is we have done, in my opinion, the hard part, okay? But these are all, remember one more time, I'm going to kind of highlight this. This is X-intercepts, okay? So to find an X-intercept, you always take each factor, set it equal to 0, and solve it. And since we have a little more work to do, what I'm going to do is come over here and just write my X-intercepts down very quickly so that I can clear off some room. So we know we had 3, 0 for 1, we had -4, 0 for 1, and we had 2, 0 for 1. So those are my X-intercepts. So now, in addition to X-intercepts, we have to find a Y-intercept, right?
Mm-hmm.
Okay, and so a Y-intercept you find differently. So I'm going to give you the rule to find that. So to find a Y-intercept, what you do is you make all x's equal to 0 and simplify. So basically what that means is we're going to go back to that original problem where they gave us those factors. We're going to take out every x, we're going to plug a 0 in its place, and we're going to see what we come up with. So instead of x minus 3, I have 0 minus 3. And instead of x plus 4, I have 0 plus 4. And then instead of 2 minus x, I have 2 minus 0. And then remember, you want to do your order of operations first. So you want to do the addition or the subtraction that's inside those parentheses, and then we'll multiply everything together. So 0 minus 3, -3. 0 plus 4 is 4. 2 minus 0 is 2. And then what we want to do is multiply. So -3 times 4 is 12, or sorry, -12 times 2 is -24. So what that means is your Y-intercept is -24. But once again, Hawks is pesky, and they say we want it as an ordered pair. They won't just take -24 for an answer. So remember, ordered pairs are always x first, but you made all your x's 0. So that is 0, and then what you just found was your y value. So 0, -24 is on your y. Here's your Y-intercept. And then I'm going to make a little note right here. On all of these, there is always only one Y-intercept. Now, there's definitely more than one X-intercept, but there's always only one Y. That's it. Can't have any more.
Okay.
Now, here's what you would do to find a graph, okay? So I told you I'm not really the world's greatest at drawing graphs, and I'm not going to be able to draw you 4 of them on here because I really don't think I could get all 4 on here, and I know they make you pick from 4, but I'm going to draw you a couple ones, and I'm going to show you kind of how to use some process of elimination on these graphs. You have found everything that you need to pick now. So what they're going to do is they're going to come in here and they're going to draw a couple of graphs that look like this. So give me a sec. And I'm going to do this, and I'm going to put like -24 down here, and I'm going to do this, and I'm going to put like +24 up here. And let's see. Oh, that's a little off. Sorry, we're going to pretend that's a 3 right there. Okay. So I'm going to go like this, and then let me draw another graph over here. And we're going to have -24 down here, and we're going to have +24 up here. And let's see, on this one, it's going to look something like that, okay? So here's what I want you to notice. If you look at this, you have your x-intercepts. They both happen to have the correct intercepts. Notice both of them cross the x-axis right there. That fits this one right here, -4. They both cross right there. They both cross at 2, right here at 2, right here at 2. That fits this one. They also both cross at 3. Here's 3. Here's 3, that fits this one. The difference really in this one is that this graph up here, the very, very first one that I drew, let me get like black right here, that goes through +24, and then come over here and let me get some maroon, and that goes through -24. Now, based on what we know about the y-intercept, would the first graph or the second graph be the correct one?
The second.
Yep, there you go, because it's got that correct y-intercept right there. So that's why, even though Hawks tells you to pick the correct graph first, they really do give it to you out of order. You have to know the intercepts before you can pick the correct graph. So when you're doing problems like this, ignore that first, find your intercepts, and then go look at the graphs.
Okay.
That make a little more sense?
Yes.
Yes. Okay. All right. We're going to do one more that's kind of similar. Okay. But I'm not going to be quite as nice on this one. On that first one that talked about graphing, I gave it to you in factored form. In this one, I'm not going to give it to you in factored form. We're going to have to factor it, and then we can do kind of the same thing. All right, let's see. I was trying to stack y'all so I can see there. Hey, Larissa, can you hear me? I'm assuming you can.
I can hear you.
Okay, if you have a question, just jump in, okay?
Okay.
All right. So on this one, our goal, and by the way, Larissa, we are in section 5.1 right now. I'm very sorry if I neglected to tell you that when you came in. So you do have,
it's okay.
You have 3 homework sections due tomorrow. This is the middle one. Okay.
Yeah.
All right. So on this one, it says find X and Y intercepts. They always, after they say that, they always say write as ordered pairs. Okay. So once we find the X and the Y intercept, we do have to write them as ordered pairs. Okay. And then on this one, I'm going to give you this. I'm going to say f of x equals x squared plus 2x minus 3. So the good news is this is no different rule-wise or anything else than the last problem. The only thing that makes it different is you'll notice that this ugly thing right here is not already factored. And so when I say set each factor equal to 0, well, that doesn't really help us because we don't have a bunch of factors. But what we can do is factor this. And so I want you to remember this. When you're factoring, you want two numbers that multiply to be this last number and that add to be the middle number. So we need two numbers. They need to multiply to be -3 and they need to add up to be +2. Well, this is kind of nice one because you only have two choices. To multiply to be a 3, you need a 3 and a 1, right? But since this is -3, it either has to be -3 times 1 or it has to be +3 times -1. Those are your only real choices. And I'm going to put a little star by this one. It has to be this one because when I add them up, I need it to be +2. So I know that my numbers are +3, -1. So what that means now is when I come in here and I factor this, I'm going to say x plus 3 and x minus 1. Now here's the good news. Once we get there, it is exactly like the last problem. So to find your x-intercepts, you take each one of those factors and what do we do with it again?
Equal to 0.
All right, so I'm going to take that first one, x plus 3. We're going to set it equal to 0. We're going to solve it. We didn't have any trouble doing that last time, so that means that x is -3. But now remember, Hawks won't take that because they say write it as an ordered pair. And so remember, I'm going to just write it out here. That means -3 because that's my X value, comma 0. So I'm going to circle that. That is one of my X-intercepts. But it's not both of them because I had two factors. So now you got to come over here. I'm going to do this one in a different color so he stands out so you know he's kind of a separate problem. So we've got X minus 1 equals 0. And so we get X equals 1. And what would that look like as an ordered pair?
1, 0.
There you go. So there's your X-intercepts. But now remember, anytime that they say find intercepts, or this one was specific, not only do we have to find the X, we have to find the Y. Yeah, there you go. All right, so there's my X-intercepts. And in fact, you know what? I'm just going to label these just to make sure that everybody's real clear. That's an X-intercept. That's an X-intercept. To find a Y-intercept, let's come over here. And what do we do again to find a Y-intercept?
Multiply them?
Almost. What do you do before you do that? You make X equal to?
Oh, 0.
Oh, okay. So now this one, it doesn't matter where you do it. So I want to make sure that you realize that. You have right here two different forms of the same thing. That top equation is one form, that bottom equation is another, but they mean the same thing. It doesn't matter where you plug your 0 in. I'm going to go with the top equation because that's what most students do. But if you were to plug it into the factored form, it would still be okay. You'd get the right answer. So first thing I see is X squared. So I'm going to say 0 squared plus 2 times X. Well, that is 2 times 0 minus 3. So what is 0 squared?
0.
0. Okay, that's kind of boring, right? What is 2 times 0?
0.
And then minus 3 is just?
-3.
-3. And then the one mistake that people tend to make on this one is they get their X and their Y mixed up. Remember, you plugged in 0 for your X and you found your Y. So you'll notice that if you really look at your X and your Y intercepts, your zeros are in different spots. Your X-intercepts, your Y is always 0, and on your Y-intercepts, your X is always 0. It's kind of backwards. All right, what do we think about that, ladies? We good?
Yes.
Yes?
Where did the 0 squared come from?
Okay, right, let me see, I'm going to put it in a different color for a second. Okay, this right here. So see how we have X squared? So the rule for your Y-intercept is you always go back to your equation and you take everywhere that you see an X out and you put in a 0. So for instance, we really could even do this. You really could come over here and say, okay, let me look at this. The first thing that I see is an X. I'm going to come in here and erase it. And I'm going to put in a 0. And then I see plus 2 times X. Well, I'm going to come in here and I'm going to erase that. Oh, I erased the 2 also. Sorry. And I could say 2 times 0. But then over here on this minus 3, I don't have an X, so I can't plug anything into that. So it has to just stay there. And then you just evaluate that answer.
Do I always plug in 0?
If you are
Or just
finding
whatever
a
my X-intercept is?
Y-intercept. No, if you're finding a Y-intercept, you always plug in 0.
Okay.
It's just essentially it's the rule of how to find it. So that would be something probably worth probably even worth memorizing for your midterm. You know, step to finding a Y-intercept is make X equal to 0.
Okay.
Okay. All right. Do we have any other questions on this one?
No.
No? Okay. Y'all think we're ready to go talk about section 5.2 for a little bit?
Yes.
Okay, all right, so let's erase this part. I need a button on my computer screen that just erases the whole thing all at once instead of me having to like sit here and swipe over it with my finger. One of these days when I retire, I'm going to invent that. Somebody's probably going to have already done it by then, right? I'm a long way from that. All right, so 5.2, totally different topic, y'all. So sorry. It's called synthetic division. Now, here's the bad news about synthetic division. If you are prone to making sign errors, like positive and negative errors, you might just want to grab the calculator and double check your basic arithmetic, because if you miss a sign when you're doing synthetic division, unfortunately from there on out, the rest of the problem is going to be wrong. And you'll see what I'm talking about in the middle of this. So nobody ever said that you couldn't double check yourself on a calculator, all right? So if that just happens to be you, I'll be honest, it's my daughter. Bless her heart, I love her to pieces. She makes sign mistakes like crazy, okay? So, you know, if she was doing this, I would recommend she double checks herself on her arithmetic. So they are going to ask you questions that look really weird. They're going to say something like this. Is A equal, oops, let me erase that erroneous little thing right there. There you go. Is K equal to 3 a zero of some polynomial? They're going to call it P of X. They could call it F of X, but in this section, they call every one of them P of X. So please don't let that alarm you. P of X equal to 7x cubed minus 25x squared minus 9x minus 12. So there's your question. So is K equal to 3 a zero of that ugly thing? And then they'll say, if not, find P of K. So to be honest with you, half of the battle in this problem is really understanding what they're asking you to do. And I'm going to be real honest with you. There are other methods to doing what we're going to do. But the reason I'm not going to let you do the easier method today is because I know what's coming on Friday. And so you're going to have to do synthetic division for what's coming on Friday. So we're going to do this with synthetic division so that you can learn it now, so that you're not learning something else in the whole process of what you're doing on Friday as well. So when they ask you if K equals 3 is a zero, you could take out all your X's over there, plug in a 3, and see if you get 0 or not. That answers your question. But that doesn't do synthetic division. So we are going to do this problem with synthetic division. So this is how we're going to do this. In synthetic division, you draw yourself like half of a box, like an L shape. And at the top of this, so when you're doing this distance right here, the length of this, you're going to have 2 rows of numbers in here. So make sure to make it that tall. You're going to have 2 rows of numbers in there. So make it a little, don't make it just tall enough for 1 row of numbers. Now, the top row of numbers is nothing but the coefficients of your polynomial, this. Not the variables, just the coefficients. But make sure to leave enough space so that you space them apart. So when I say coefficient, look at this very, very, very first term right here. This first term, 7x cubed. The coefficient is the number. So the very first thing that's going to go right here is 7. No X, no cubed, no nothing, just the number, the 7. All right, what's the number in this term?
Negative 25.
Right, and you are correct. Since it was minus 25x, we got negative 25. Okay, what's the number in this term right here?
Negative 9.
Negative 9, all right. And then last but not least, what do we have over here?
Negative 12.
Negative 12. Okay. Now the trick is, by the way, you have to have those in order. So make sure that you go x cubed, x squared, x, and then your constant. You can't take those and just jumble them all around as you choose. They have to go in order. And then kind of on a parallel is this number over here, K equals 3. We have to give you that in the problem. So since we tell you 3 right now, we're going to put a 3 on the same line as that, but outside of the box. So this is essentially your setup. You've got the number that we're testing for K on the outside, and then all of your coefficients on the inside of the box. So here we go. Here's synthetic division for you. the way that you start is you take whatever number is first and you drop it below the box. Don't change the sign. Don't multiply it by anything. Don't stare at it too long. Take whatever it is, drop it below the box, period. End of story. Now, anytime that you have a number below the box, you multiply it by k. So 7 is below the box. Our k in this problem is 3. So what is 7 times 3?
21.
21. And I'm going to draw you a little dotted arrow. You put it catty-cornered in the next row. So you kind of diagonal up and you put it right underneath that next number, which is negative 25. Now, anytime that you have two numbers, one on top of the other, right in that box, you add them. So what's negative 25 and 21?
46. Negative 46.
Not close. Hang on. One's negative. So you find the difference between the two of them. And so that's going to be negative 4.
Oh, so wait, we're subtracting them?
No, you're adding.
Oh, no, it's a negative. Okay, yeah.
Remind me again, y'all, I won't pick yellow. That's hard to see. I'm sorry. I was trying to do them all in different colors. Yellow's a bad color. All right. So we get negative 4. Now you start the process all over again. So there's not too terribly many rules to remember. Since negative 4 is below the box, we multiply it by our k. So what is negative 4 times positive 3?
A negative 12.
There you go. So it's going to go right over here. Okay. Catty cornered up in the next line. When we have two numbers inside the box, one on top of the other, we add them. Now, both of these are negative, so I know my answer is going to be negative. And 9 and 12 adds up to be 21. So we got a negative 21. And then what am I going to do with negative 21?
Multiply it by 3?
That's exactly right. And we get negative 63. And then what am I going to do with negative 12 and negative 63?
Add
them, and that gives me negative 75. Now, when you finish this portion right here, you have finished this problem. You just haven't interpreted the answer yet. So you can't keep going because you don't have any more coefficients to fill in up there. So when you get to this little negative 75, you have gotten there. So the only number that matters in this whole setup is what you ended with, right there. So they asked you two questions. The first thing they said is k equals 3 a 0? The answer to that is no. The reason it is no, if k equals 3 is 0, this number at the end is going to be 0. And so I'm going to say no, and then I'm going to say because, just since these are your notes, the last number is not 0. So I don't care what that last number is. It doesn't have to be negative 75. If that last number is 0, then the k was a 0. If that last number is anything else, then k was not a 0. Okay. But here's the good thing. They said, okay, so is k a 0? Answer's no. They said, if not, will we fall into that? Find p of k. Well, guess what? That very last number, p of k, guess what it is?
Negative 75.
Yeah, there you go. You don't have to do any other work. You've already done it. Whatever that last number is, there it is. Now I want you to look at this for a second, and I want you to think back to our negative 25 and 21. Do you see how I said where if you make a sign error, it's going to be wrong from there on out? Because everything builds on the last number that you had. So that's why I say you got to be real careful on your arithmetic on these. It's not that the concept is really difficult. It's just that when people get to doing these and we get to flying through our homework, because believe me, I was a student for a really long time, guys. I flew through my homework too because I wanted to get done and go watch some TV or go do whatever, you know. But if you mess up on your positive or negative, you're sunk for the rest of them. So if you miss one on HOTS, that is the first thing I'd go back and look at is, did I make a positive or negative mistake someplace? All right, let's try another one because nobody ever learned anything off of one. Okay, so let's do another one of these. So let me get rid of this. And this one's going to be longer. just so I don't want you to think they all have to be x cubed. So when I went in here, when I went into y'all's homework, I picked one that was a little longer as well. All right, so on this one, I'm going to say, now I picked 3 again. I'm sorry, please don't think K always has to be 3, but here we go. Is K equal 3 a 0 of, and this time our polynomial is 8x to the 4th minus 30x cubed minus 9x squared plus, well, we got big numbers today, 91x, and then minus 30. Whew, those are some big old numbers. And then once again, if not, you're going to have to find P of K. Now, by the way, the good news on section 5.2, I know there's not a lot of good news when you have 3 sections due at one time. This is it. There are no other instructions on section 5.2. Every single one of them looks exactly like this. They just changed the K and they changed the P. So they're all synthetic division problems. You're going to practice it on every single one of them. So we're going to set up our synthetic division box here. And the first thing that we're going to do is put the numbers inside the box. So what's the first number going to be?
8.
8. Then what's next?
Negative 30.
And?
Negative 9. 91.
And?
Negative 30.
Perfect. Okay. And then what goes on the outside of the box?
3.
3. There you go. And then remember, to start your synthetic division, you always take whatever that first number is and drop it straight down. Don't do anything to it. Just drop it. Okay. So now, what do you do with the 8?
Multiply it by 3.
Okay, so 8 times 3, I'm going to draw a little arrow right here. 8 times 3 is 24. And what are we going to do with that negative 30 and that positive 24?
Add them.
And
so
we get
negative 6.
There you go. What are you going to do with negative 6?
Multiply it by 3.
And we get negative
18.
And then we're going to add those. And now we're getting big numbers. Negative 27, kind of ugly. And then negative 27 times 3, that one may be one that you don't know off the top of your head. If you don't, you can grab a calculator. I promise you it is negative 81. So then I have positive 91 and negative 81. What is that?
10.
10. There you go. And 10 times 3 is what?
30.
And negative 30 and positive 30 is what?
0.
0. Now remember that I told you the only number that matters is this very last number. This right here, all of these numbers in here could be a herd of elephants. We don't care. We worry about that last number. So that last number is a 0. So the first question is K equals 3 a 0? What is the answer to that question?
Yes.
Yes, it is. Now, it goes on to say, if not, find P of K. But since you said yes, are you finding P of K now?
Yes.
All it says is if not. Yeah, you don't have to find P of K because the answer was yes. If they made you, by the way, P of K is always this number, it would be 0. Okay. Kind of get the hang of it?
Yes.
Now, here's the
This
killer.
one's easier. Oh, no.
Yeah, here's the killer. We never lead with the, bombshell, okay? If we did, everybody would run screaming from the room. It's the way that it is, I know y'all probably think us math teachers are these evil people that come in and go, okay, now that you think you've got it, let's see what you can do with this. We really don't do that, I promise. But now listen, especially Larissa, because we talked very briefly about section 1.6 before you got here. If you haven't done section 1.6 before this one, we're going to have to talk about that in the middle of this problem because this one has imaginary numbers, which makes it a little harder, okay? And 1.6 was all about imaginary numbers. So this one says is K, which is equal to negative 2i. You know off the bat, this one's going to be harder. A0 of P of K, or no, I'm sorry, P of X, they call it P of X, which is going to equal, and I'm going to kind of move down here a little bit so I have a little bit more room, 5x squared minus parentheses 3 minus 6i x plus parentheses 8 minus 6i. Whew. That's ugly, y'all. Now, y'all agree that one just looks worse, doesn't it?
It's terrible.
Mm-hmm. I know. That's why I didn't start with this one first. But I didn't want to leave without doing one because then y'all get to your homework and be like, that woman lied to me because she didn't do anything like this. So here we go. Your setup is the same. They ask you if it's a 0. If not, we're going to have to find P of K. To be honest, I haven't done this one. I don't know if it's a 0 or not. We'll figure it out together. First thing you got to do is set it up. So what's the first number going to be inside my box?
5.
5. That's the only easy part of this whole problem. Now, I want you to notice, anytime that we're writing these, the coefficient is always everything that goes with it. And so it's going to be for the x, it's going to be all of this, every bit of that. So it is going to be negative parentheses 3 minus 6i. And that does not look like an I, that looks like a U. So hang on a second, let's make that look a little better. There we go. All right. And then the same thing over here, all of that is your coefficient for over here. So it is going to be 8 minus 6i. And then what is your K in this problem?
Negative 2i.
It is. There you go. Now let me stop right there. We're going to make one change to this, but before I make one change to it, do we get where we got all of these sets of numbers from?
Yes.
Okay. The only change I'm going to make, I want you to look at the red one in the middle of the screen. Do you see how it has a negative out in front of that parentheses?
Yes.
That's not a really good thing, because what that means is that negative is supposed to change the sign of everything on the inside of the parentheses. And so I personally think it's going to be easier for y'all if you go ahead and do that rather than having to remember that that negative is going to change the signs. So instead of writing it as negative parenthesis 3 minus 6i, I'm going to come in here and I'm just going to go ahead and distribute that negative. And if we distribute that negative, that's going to make that a negative 3 plus 6i. Because remember, and I'm going to draw you a little arrow up here, that negative has to go with both of those things. So it isn't just negative 3 minus 6i, it's negative 3 plus 6i. All right, so here we go. How do we always start synthetic division?
Drop that 5.
Bring down 5. There you go. What are you going to do with that 5?
Multiply it by negative 2i.
Okay, so what do you think you get when you get 5 times negative 2i? Don't think too hard. 5 times negative 2 is negative 10, and then what does it have with it? An I. There you go. So when you multiply 5 times negative 2i, you get negative 10i. Now, this is where students generally tend to kind of go off the deep end, because they look at this and they think, okay, I'm supposed to add those two things. Oh my gosh, what am I supposed to do? I don't know. Okay, it's like combining like terms. The two like terms here are the positive 6i and the negative 10i. What would a positive 6 and a negative 10 be if you added them up?
Negative 4.
And then you just bring the I with it. But what didn't have anything that could be combined with it?
Negative 3.
There you go. So when I add those up, we get negative 3, because you just kind of have to bring it down. You can't forget about it. And then your positive 6i and your minus 10i are negative 4i. Now here comes the real doozy. If you can do this next step, you got it. You are home free, okay? What are you going to do now?
Multiply, or do you read, multiply the negative 2, but.
The negative 2i times what?
Yeah. -3 minus 4i.
There you go. Okay. Now you notice I came off to some scratch paper because we're going to need it. All right. So here we go. Remember, I'm going to just draw little arrows reminding you that goes with both of those. Okay. The first part's not the hard part. So -2i times -3. First of all, negative times negative is going to be a positive. 2 times 3 is 6. And then you got to bring the I with you. So that's just 6i. Now we're going to do the next part. -2 times -4. What is that?
+8.
And then you have I times I. What is I times I?
I squared.
I squared. There you go. So it looks like on face value, you have 6i plus 8i squared. But what we learned in that section 1.6 is this. So if you don't remember, write this down. I squared is always equal to -1. Not I is equal to -1. I squared is equal to -1. So what we can do down here is a substitution step. I can come in here, I can take this I squared out, and I can put in what it's equal to. Well, what I squared is equal to is -1. And so it was 8i squared, which really means it's 8 times -1. Well, what is 8 times -1?
-8.
-8. So what you really have over here is 6i minus 8 when you simplify it. And so when we come over here, we're going to plug in 6i minus 8.
So the I goes away on the 8.
It does. The reason the I goes away on the 8 is because we took the I squared out and put what in its place?
Oh, the -1. Okay.
The -1. There you go. Now you can't do that on an I. You can only do it on an I squared.
Okay.
Okay. So, and by the way, you technically, you know, everything in math, they always say either simplify or reduce or whatever. And I squared is not simplified. And so anytime you see it anywhere in any math class, you always want to replace it with a -1. It's one of those rules. So now that you know that that is 6i minus 8, you put it back over into your synthetic division. And I want you to notice what happens. You'll notice that the top row and the bottom row are flip-flopped, but that's okay. You're just adding. So what can combine with that +8 in blue up there? What can combine with it?
-8.
Well, +8 and -8 do what?
Cross each other out, 0.
What about -6i and +6i?
0.
So is k equal to -2i a 0?
Yes.
Yes, it is. Now here's the good news. I'll go ahead and because it's 8:30, so we'll go ahead and get ready to end on the good news. The good news is there's only one of these.
Yay.
All of the rest of them are numbers. They don't have eyes in there. All of the rest of them are like that. There's only one that's got the eyes in there, and it is only a squared. So you'll notice when it's a squared, you only have 1, 2, 3 of these columns. So that's all you're going to have in this. It's not going to be one of the really long ones like that second one I did that had like 5 columns or something. It won't be that. Okay. All right. Now, before we get ready to end, I'm going to give you one piece of information or one piece of advice. Make sure that you get your synthetic division down. And then I'm also going to tell you that using a graphing calculator on the next section, which is coming up, section 5.3, a graphing calculator may help you out a little bit. So if you have one at home, that's great. If you don't have one at home, I recommend over the next couple of days that you check out something called Desmos. It's DESMOS. It is online. It is a free graphing calculator. I promise you it's used by educators worldwide. There are no viruses or anything like that in it. So a lot of times if you get things that you have to download, you run into trouble of messing up your computer. This one is all housed online. It's a really good one. So if you're looking for a graphing calculator when you start that next section, try that one. Okay.
Okay.
All right, ladies, anything else that we can do for you really quickly before we go today?
There was a question I had.
Okay.
I can't remember what section. I think it was the 1.6 section, and they said find a conjugate or.
Good. Okay, yeah. The issue with that is you just have to know the definition of a conjugate. And I could write it out for you, but I think it's going to be easier if I just show it to you. Okay, so let's pretend for just a second that I gave you this number. 3 plus 4i. Now, just as a reminder, this whole thing is one imaginary number. Every imaginary number has what we call a real part and has what we call an imaginary part. So they have something like a plain old number, like a 3 or a 2 or whatever at the front, and then the imaginary part has the I, and we write it second. A conjugate simply means take whatever sign is in the middle right here, not up front, in the middle, and change it. So the conjugate of 3 plus 4i would be 3 minus 4i.
Okay.
Now you notice I didn't change the sign of the 3, right? Just the sign in the middle. So if we had something like this that let's say was negative 2 minus 8i, that's another imaginary number. What would the conjugate of negative 2 minus 8i be?
So negative 2 plus 8i.
There you go. That's it.
Okay, makes sense.
Okay. Just remember, you don't, a lot of times people want to change both signs. So they want to change the sign in the front and the sign in the middle. You just change sign in the middle. That's it. Okay.
Okay.
All right. Anything else, ladies?
No.
Okay. All right. Well, then I will go ahead and let you go. Thanks for joining me this evening. I appreciate it. Remember, if you've got any questions or anything like that, you know, you can always pop in and see me. But I know I'm on the Corsicana campus and a lot of you aren't there or whatever. And Miss Young is on the same campus as me. So I'm sorry about that. You can send me an email, you know, whatever you need to do. Okay. Just don't wait till 11:30 to start tomorrow night because you got 3 sections. Okay. All right. Y'all have a good one, okay?
Thank you.
Bye-bye.
Bye.
Bye.